not just talking about using AI, we are talking about the transformer architecture. This is the engine inside GPT-4, Claude and Gemini. By the end of this video, you will understand how exactly these models think and how they handle billions of words at once. Slide you can see you have heard the acronym GPT. Let's demystify it. So GPT generative stands for it creates new content. Pre-trained it stands for already read the entire internet before you ever talk to it. Then transformer, this is the most important thing. This is how it's the specific mathematically structure that made the AI revolution in possible in 2017. Before this, AI was slow and had a short memory. Slide 3, you can see the how does computer understand the context using the self attention mechanism. So look at this sentence, the animal didn't cross the street because it was too tired. As human we know it refers to an animal, but for the computer that is hard to understand. Self attention allows that to understand, or it makes it capable to understand better or each and every word in a sentence simultaneously and assign importance weights. It creates a web of connection, so it understands that it is linked to an animal or not the street. So in this slide 4, you can see the old AI models like RNN were like a person reading a book one word at a time, left to right. But if the book was long, they would rather forget the beginning by the time they reached the end. And transformers are different. They are reading the entire page at once. This is called parallelism. Because they can process everything simultaneously, we can train them on massive GPUs, which is why LLMs have gotten so big and so fast. You can see encoder versus decoder model. So encoder use understanding task, good at classification and sentiment analysis, but example decoder only optimized generation GPT-4 and most LLM uses only this design. So basically decoder only architecture uses mostly in today's world. So think of a transformer block like a filter in a water treatment plant. So now in this slide you can see the data goes through the layer normalization. Layer normalization keeps signals stable and training efficient. So in this one you keep things stable and attention had to find meaning and then pass through a feed forward neural network to refine that meaning. We stack 96 of these blocks on the top of each other to create GPT-3. It's a layer upon layer and layer upon layer of deep refinement. So here the power of scaling. So why scaling works, as we increase parameters and data emergent abilities. So appear logical reasoning means layer by layer, zero shot learning, translation coding, right? Translation and coding. So without transformers efficiency, we could never reach this complexity. So we have trained that 1.8 trillion parameters and established the GPT-4. So these are some examples of the memory vector database. So in memory vector database, we have lots of different databases like Pinecone, Waviate, and we have that open source like Apache LansDB, then Marco, ChromaDB also we have. And then PostgreSQL, Cassandra we were using previously. Currently, most of the time we are using that ChromaDB, then Pinecone, then Phase. These are the vector database. Now, These are the efficient storage we call it, okay, to save our chunks or our embeddings inside this vectors, vector DBs. So retrieval augmented generation, one you can see, but even the best model have cutoff date. They or they hallucinate. That's where the RAG comes into the picture. Instead of AI relying on its memory, RAG allows the AI to look a vector DB like digital library to find the exact document it needs and read it before answering you. It's the difference between a student taking a test from memory versus a student taking a test from open book. The open book student will always perform better than the memory, because open book will be more accurate because he knew and he can just directly search easily and then he can put the answer to you. Okay. Yeah. So in RAG pipeline, we have indexing, retrieval, augmentation, generation. So in indexing, we have load, chunk, embed, and store documents in vector DB. Retrieval, we have embed the user query and find top k relevant chunks. Then augmentation, insert retrieved data or text into the LLM prompt as context. Then LLM answer based on the provide factual context, which will be the generation part. Currently the AI field is moving at light speed, but the transformer remains the foundation. If you understand attention and embeddings, you understand the core of future. If you found this breakdown helpful, hit the subscribe button and check the description for the link to these slides and so. I will see you in the next video.